I think we talked about difference lists a little bit, which basically turn list operations into functions that compose, which is really nice. And then also it speeds up our right versus left folding problem or appending problem. So difference lists are pretty cool. So now we're going to talk about 15, 1, 2, Church and Scott coding. So this is something that I've heard about a bunch and I've not done anything. Why is it? I mean, it says that I'm live, but why is this session not going? There it goes. Okay, I just needed to update my stream manager. If you sent something in chat viewer, I missed it, so my apologies. Okay, so we're gonna talk about Church and Scott encodings, and I've seen this talked about before, but I don't know what it is, so that's good. We'll learn something new today. So Church and Scott. So right after map and filter, functional programmers are introduced to folds. The most common used folding function in Haskell combines the elements of a list nesting to the right. All right, so we have fold, folder. We've implemented, or this is probably in the standard, so standard library, prelude. So B is our accumulator function, and we need a function that combines an A with a B to produce a B. It's probably this. So it doesn't matter what our function is. Yeah, we need our accumulator here. So folder fvxxss. XS. I can speak English, I swear. For some reason I seem to be having trouble today though. I don't know if you noticed, but maybe you did. All right, so all we can do is apply F to V, and we need to somehow be able to combine it. So I think that's folder. So F has to take an A and a B to make a B. So we're giving it an A, and then we're saying that this is going to be a B at the end. Okay, got it. All right, so you could write something like some, list of integer yeah, I mean, it's gonna complain because some already exists. So, oh, we're missing an underscore here. That should fool the compiler, I think. Can we fool the compiler that way? Yes. So HLint is looking specifically for something like this. So we can fool the compiler that way. or something like concat. Nope. Isn't that right? There you go. But we really want to put these together. So yeah, this is just point free, so we can just leave it like that. Wonderful. Okay. So it says, beneath its simple interface, foldr holds a secret. Describing how to fold a list is equivalent to describing the list itself. Let us define the type of encoded lists. That's interesting. E-list A. For all B, A, B, 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 B. And we'll need rank and types for this one, probably. Not probably, we do need it. And now what's this complaining about? Wants us to use new type, which is fine, I suppose. Somebody mentioned last time that it might not be fine to use new type there, but I'm not entirely sure. All right, so now we need some helper functions. So if we get an A, we want to make a E-list A. Okay. Interesting. Ah. E-list fold. Fold. Interesting. The type E-list is called the church encoding of lists. We can define such an encoding for any algebraic data type by swapping the normal data type definition with its fold function. Of course, many encodings to and from lists are possible. There's a bunch of examples here. But the title of the thing is called Church Encoding of Data Types Considered Harmful for Implementations. Kind of interesting. The reason that this encoding is renowned is that it also provides a translation for every primitive list operation. Checking whether it's empty, building cons and nil, and destructuring with head and tail. That's cool. So we have like nil. So it's like interesting. We're gonna have to think about this probably. There's an exercise at the end, so that should probably help us through this. Has anybody worked at these before? There's only one person, so I'm just asking you. So F can only be applied. Nice. How's it going, Tolt? So we can only apply F to X. FV. Hey, Prutz, what's up? Yeah, the Twitch stream manager thing is being a little messy right now. Yeah, we're learning about church encodings. This is pretty cool. I don't have any intuition for this, so I'm hopeful that maybe this will help with some of the logic required later. So it's like you have a function that's applied to A. So we're like waiting for an A, and we'll describe something that goes from B to B. Something like that. And like, so this X is like outside. Yeah, maybe. They're not straightforward to me yet, but like maybe they'll start to make sense towards the end of the, as we start messing with them. All right, so there's cons. We can write null. I wonder if it will help to try and, well, I mean, the data type is just elist A, isn't it? Church encoding for empty list is fuldar. For comma is uncurry. Huh. Oh, yeah. This right here, basically. Something like this, anyway. Yeah. So this is going to take an A and an elist A and make is that right? I think it's right. It's a cons operation, so you can only cons things of the same type. It's not like you can change this to a B. Okay. It is showing 2 viewers now, by the way. Also, hi, Prutz. I don't think I said hello. All right. So let's see if we can guess what this is. So this is gonna have to return true or false. So I mean, we could do. Okay, so we gotta give it. Okay, so this is f and v. This is our accumulator. This is our b. And we're saying basically if we have any f and v produce false, otherwise produce true. I think that's it. You see, foldr takes an argument to return for empty list and a function to apply. Yeah. I think I'm slowly getting it. So I don't. Hmm. I wasn't expecting that. So it's like just forward F, and then otherwise, like, you're gonna fold on an error? This is weird. Not fold, excuse me. This is just, yeah. This is just const F. Wait, what's F? Oh, just const, sure. Sure. I'm confused. So for arbitrary ADT, church encoding will be a function with as many arguments as this ADT has constructors. Oh, interesting. Okay. How does this work? So XS takes a function A to B to B that just returns A. Otherwise, if we try and do anything with this B, that will be an error, I guess. We'll have to test this stuff, but I think this has to do with the way I think this is lazy evaluation. Like if you weren't in a lazy language, could you do this? I don't know. I guess you would just throw an error. I don't know. Unsure. Ooh, this one looks hard. What? Maybe better do this with safe head and then extract. I'm not, I mean, maybe. HT G G H T F. This is brutal. I do. I think I've used safe head before, to be fair, but I don't see how am I going to do that here. Would I just do from elist? I mean, you'd have to do from elist, right? You'd do a round trip. You'd say like from elist safe head to elist, or from maybe something. I don't know. Or you're saying implement safe head as if it was an elist. Maybe that's possible. I'm not entirely sure. Yeah. Well, for sure, but I think that I think the lazy evaluation is why this works. Like why head would produce something if you operated on an elist greater than, or an empty elist. We'll play with this later. I'm not terribly concerned about this. So collapse lambdas. I don't know what that means yet. Oh, yeah, okay. Sure. And this is just const v. I mean, technically this is flip const, but yeah, I don't really know what this is doing yet. Like, I'm a little confused. All right, let's poke around some types. So this is like an inner F, okay, G. So this is just a similar function to yeah, you might be right. I mean, we can just do it. It's not a big deal to me. It's just gonna complain, which is really annoying. It's not that annoying. It's only kind of annoying. All right, so what's T here? Okay. And H is just an A? Interesting. Okay, so this is actually a value? Why is this just an A? What's F? F should be that. B should be B. See, I would have... Wait a second. Why is that just an A? Shouldn't that match this one? Is tail 1, 2, 3 a list? Yes. Yeah, I'm embedding an elet. Oh, right. Wait a second. Oh my goodness. So you're thinking of last. So last is different than tail, right? No, that's okay. That's okay. I thought you were sending me down the right path. But I misunderstood. What I'm a little confused about here is the type of XS here. How is this the type of XS? Oh, I see. Because B is polymorphic here. You can have any B. So that's why this looks funny here. So in this case, our B is just this thing, right? So it's A to B to B. Wait, but what's this B here? Oh, it's just this, right. So B is this whole thing. So A to B to B. And then B. And then the next one, I guess. This is rough. So like, yeah, this seems pretty tough. This is the kind of recursion I have trouble with. Because we're like, well, this isn't really recursive. Kind of is. Anyway. Okay. It says the bad news is that computing the tail of a list involves a huge amount of work. Church encoding works well for composing fold functions, but not so much for other functions. Hang on, I gotta shut the door. Ugh. There's like, yeah, there's definitely some amount of needing to tail of a regular list via fold R. That's a good question. So we need to we do need some amount of recursion. But how do we recurse into XS? Recursion is already inside fold R. Sure. What? What could it possibly want me to do here? I don't want to do that. That's hard to read. Hey, Type Rat. I'm trying to understand how this recursion works for church encodings. So we've defined a type for church encodings, and this is a bit rough to understand. So there's definitely some amount of like recursion that I'm not getting with this. Well, this is another example, but the major example that I had a lot of trouble with is the gosh, I'm blanking on these freaking names right now. Extensible effects. So like we learned how to use extensible effects, and we also implemented an example of extensible effects, but the recursion is really hard for me to understand. I don't see any way to implement just it's really hurting my head too. I've had a lot of headaches from these experiences recently. I mean, they're like good headaches, right? But there's some amount of like, I need to sit down with a piece of pen and paper and like just write down a few iterations of the recursion happening, and I think it will help make sense of it all, you know? But I haven't done that yet, and I don't have the time to do that right now. So it's like I'm kind of just going and hoping that I can continue working, and that like later down the road I'll feel more comfortable about doing this stuff. That's the best I can do right now. So this is kind of interesting that this, like, watch this. This is going to be wild. Actually, I want to just keep this implementation here. So watch HLint do its work here. This is pretty crazy, I think. So we're gonna do this. We're gonna fold like this, and then we can also just reduce. Oh wait, hang on. It didn't. It says that, but then it didn't do it. I thought it's supposed to do it by itself. But anyway, like you can just get rid of this, and it seems to think that this is a legal implementation. So let's find out. So it's gonna be I'm trying out a new terminal emulator, by the way. Well, it's not new. I mean, it's been around for a long time, but it's new to the stream. This is not, it's id. Oh, you're saying what I wrote is id. It might be. Yeah, so first, I don't know that maybe this is just wrong. Sorry. By the way, hey, what's up, Soding? How's it going? If you see any screen tearing on from this terminal emulator, could you let me know? I'm testing it out because I really want this sort of behavior to see if I like it. And, you know, there's like movement and stuff and different layouts. I think this is similar to like i3, but again, I'm just messing around, trying it out. I do like these split terminal things, emulators. I don't know why I'm having a hard time saying split terminal emulators. Okay, anyway. No, this just fails. Yeah, so this doesn't work. I mean, I just guessed. Wait, eventually we're gonna hit empty list. Wait, this has to happen. Right? I don't think this is right either, but... Oh, yeah, we can't do this. You can only have excess here. Yeah, I'm not thinking that carefully right now. So we need to... I think this is id, by the way. Maybe. Or this never terminates. One or the other. Oh. Yeah. Infinite loop. Think about what foldr actually does. Okay, I'll do that. So we need to take an X. And we're folding on the right, so we need an accumulator. And we need to do something. That accumulator clearly needs to be empty list so that we can put stuff together. I think. And we need to make a list. So I think this is really correct. And I think this is correct. But somehow we need to... I mean, I don't think it's correct, actually. We need to... What is tail for empty list? I mean, I think tail of empty list fails. And that is just X. Oh, that fails too. Right. Oh, wait. I'm stupid. But you need this. Oh, I've redefined tail. God. I'm like stupid right now. Yeah, there we go. That's the error I was expecting. That's empty list. Oh, I see what you're trying to say. So our accumulator is not actually empty list because our accumulator must exist. It's something like, it is like error here, I think. I wish I was smart. That would be helpful. I don't understand what I'm trying to do here. You know, I know 100% that I've done this before, which is depressing. Recursion is hard. Maybe I should write it out. But I don't have like a good drawing program. I kind of want to keep trying. Like, I do want to figure this stuff out. Just like, I hate bumping my head up against this stuff. It's not very fun. Because like I'm not getting anything out of it right now. Yeah, we just did. Like, we literally just looked at it. Yeah. I mean, I've used Foldar a bunch. That doesn't mean I'm find this intuitive. I feel like every time I encounter this, it's just not in my head because I don't do it enough. Yeah. It's like, need to practice. Alright, so what's the point here? So foldable A, that's our list. What is this B gonna be? And also, how do I skip the first element? How am I going to skip? You have empty list Foldar returns that B. You have XXS Foldar returns that. Applied to X and result of Foldar applied to XS. I don't understand what you're trying to say to me. If you have empty list, Foldar returns that B. What is B? This B. Sure. I need to build up a list in the accumulator that contains everything but the first element. But how? Apparently. I mean, what if this is... Yeah, I don't feel like sitting here doing this right now. I need to do this on my own time. Just keep reading. I've done that before. It's like, this drives me insane. And like, there's an exercise coming up here, and I'm not going to be able to write it. There's no way. I'm not going to be able to figure it out. So, we'll see. We can define a function match list that turns the pattern matching primitive into a higher order function. Okay. Folder. Well, without the maybe, right? In Prelude, anyway. I assume it's like this in Prelude. Oops. It might not be. I can look it up real quick. Oh, nice. Okay. Sometimes I think it's funny that like these types of functions exist with maybe, but the original functions do not. But that might just be for legacy reasons, and uncons could be relatively new. It's like the book say write partial functions? Does the book say write partial functions? You what do you mean? Where I don't have any partial functions. You mean like this one? Well, that's a bad yeah, I mean, wait, no. That's not partial at all. Never mind. I read this differently before. Like this one? Oh, okay, I see what you're saying. Okay. Functions that aren't total, right? Or pure, whatever you want to say. Sorry, I think of partial functions like this. this function. Well, it's fully applied, I suppose. That's not a good example. Anyway, I think of a partial function as a function that's partially applied. Sorry, that's what I'm trying to say. I mean, I don't know. We can pass error inside of full dar, I suppose. I'm not so concerned about that right now. Like, making this function pure is not that important to me, essentially. Like, I don't even understand the mechanisms here, so is it that important that this isn't pure? Probably not. Okay. I mean, they're not that hard. You can just put an error anywhere. Do you mean that? Oh, maybe you mean they're not hard because the implementation is funky because you have like errors in the right, error has to be in the right place, something like that. And the typed versions errors are hard. That's probably true. Okay. So it says instead of folding on its own, it is useful to focus on the general shape of pattern matching. It turns the pattern matching primitive into a higher order function. What does this mean? What are you talking about? Pattern matching. I don't understand what that means in this context. It says note the lack of recursion in the second branch in contrast to what happened with Foldar. Okay, anyway, maybe these things are easier. Yeah. We'll spend more time with it later, though. I need to do this on my own time. I also still have the extensible effects paper in my bag, so I need to work on that as well. Okay, so my stomach really hurts again. think this is the same.